Hello viewers, Wagdaruna taking you through the story for A-Level Applied Mathematics. And this video, we are going to go through the marking guide for Math Part 2 for UNEB, U.A.C.E Uneb of the year 2024. So this video is suitable for students in Senior 6 offering Principal Mathematics as part of their combination. So these are the videos we hope to upload in this month, if time allows. So today we shall begin with the general remarks of the paper. Like I've already told you, in UNEB, after the marking process, a report has to be made indicating how the paper was, but highlighting three main things. 1, question analysis of what the question wanted. 2, the weakness of the candidates in that year. And 3, the advice to teachers so that the students do not make the same mistakes. So in this paper, we shall be highlighting all those 3 points after every question. So I encourage you to be as attentive as possible and watch the video as we make some notes. So general remarks. 1, the questions were from the topics of mechanics, statistics, stroke probability, and numerical methods. So these are the 3 parts where questions come from. There should be 3 questions in section A for mechanics and 3 questions in section B for mechanics. Then statistics stroke probability, also 3 questions in section A and 3 in section B. Then numerical methods, 2 questions in section A and 2 questions in section B. That gives a total of 8 section A, 8 section B, where 8 in section A are compulsory and here you choose any 5. So the performance of candidates in U.A.C.E 2024 was a little poorer than that of the year 2023. In short, there was a little decline. And the reason is that the paper was a little more difficult than that for 2023. The quality of work presented by candidates was also a little poor. So that is why we always encourage you, before you sit for UNEB of 2025, get time and watch and go through the papers of UNEB 2024. So that you get a picture and don't repeat the same mistakes which were made by the previous candidates. The time allocated of 3 hours was adequate for the paper. So don't say that the time was little. The 3 hours was well calculated and they realized that it will be enough for you to answer all the 8 questions of section A and 5 questions of section B, unless there's more crossings. That's what makes the time not to be enough. So before you begin, make sure you have chosen the 5 questions wisely. Then this table shows a summary of questions which are well done, and this is the list. Questions which are poorly done, this is the list. And most attempted questions, this is the list, and also least attempted questions, which is this. So section A, we shall begin section A, question 1. 2 events, A and B, are such that probability of A is this, probability of B is that, probability of A intersection B is this, and they said find the probability of A complement slash B complement. So the slash means given that. So 1, because of this slash, it means that the numerator should be A complement intersection B complement. But we don't have it yet, so it is better you first get the probability of A complement intersection B complement. So to get it, we know that A complement, if this, you see here the complement is on each event. So if it goes out, even this sign should change. So in short, this probability is the same as probability of A union B in brackets complement. Now this A union B complement is the same as 1 minus probability of A union B, which we are seeing here. Okay, now this A union B, the formula is standard, is there in the logbook. It is probability of A plus probability of B minus probability of A intersection B. So when you substitute, you shall come up with 1 is here. Use brackets very well. Brackets should be used very well. So probability of A, probability of B, probability of A intersection B. So when you subtract, you come up with 0.25. Now that I've got that, I can now get the probability they wanted. So probability of A complement slash B complement, or A complement given B complement has occurred, will be equal to probability of A complement intersection B complement over what comes after the slash, which is probability of B complement. So this one is here. The complement is got by subtracting, so it will be 1 minus this, and in the end you come up with 5/6. So that's what they wanted in that question. So the analysis, the question required candidates to find a conditional probability. So you're supposed to know what a slash means. Slash means A given B. If they write like this, it means A, probability of A given B has already occurred. And how is it expanded? Numerator will be intersection of both, and denominator will be what comes after the slash. So failure to state the conditional probability was a challenge. Failure to get the equivalent of this, how to get this. So it was easier. You can either choose to use set Venn diagram or you use contingency table. So for me, I use the certain law to pull the complements out. But if you use a set Venn diagram, you'll still be able to get that probability. So if you use a Venn diagram, that probability will be what is outside here. For example, if this is A, this is B, what is outside here will be this probability. And here the total will be equal to 1. Total probability is always equal to 1. So that means we can easily get the value of X. So then failure to obtain accurate probability values. Then advise teachers guide students to use the Uneb mathematical tables, because this formula for union is already there in the table. Then encourage students to ensure a high level of accuracy. If possible, use fractions. But if not, don't round off to a whole number. Use 4 decimal places. Then emphasize the use of contingency tables. If not contingency table, then it has to be Venn diagram. So Venn diagram will give you a correct answer, though it will be a little longer. So question 1 was from the section of probability and statistics and probability, and the topic was probability theory. Then question 2 comes from the part of mechanics. It says the resultant of 2 forces P and Q is a force of 15 newtons acting at an angle of 50 degrees to force Q. Given that the magnitude of force Q is 12 newtons, determine the magnitude and direction of the force P. So here we shall need to draw a diagram. If there are 2 forces and the angle between them is not 90, then you have to use parallelogram. So this is one force, this is another force. This angle is not known, and they want it because they said magnitude and direction of P. So when you complete the parallelogram, we shall reproduce this force here, and also this force reproduce it here. Then a line from here to here will represent our resultant. And they told us the resultant is 15. And that's an angle of this to force Q. So force Q is here. So the angle 50 will be here. So now we can use cosine rule because I have this, I have this, I have this, I have this angle, so I can get P using cosine rule. So substitute and use a calculator, and that will be the value of P. Now this is the magnitude. We also need the direction. Direction, you can choose to use sine rule. Sine rule means this goes with this, and this goes with this. So come up with sine 180 minus theta over 15 is equal to sine 50 over P, which is this. Then next is to bring this on this side to come up with this. Then arc sine, that gives you that. There are two angles. Then theta, for theta to be obtuse, because if you look at here, sorry, this one is an obtuse angle. It is greater than 90. So this one will not work. Therefore, we shall take this and be able to get the value of theta, which is acute, like that. So if you had taken this, it means that the value of theta you'll get here will be obtuse, which is not okay, because obtuse happens when this magnitude is smaller than any of these two. This is what I'm trying to mean. If the resultant is 0, if the resultant is smaller than the individual forces, it means that the way you draw a parallelogram changes. It will be like this. Now you're going to notice something. So this length here will be shorter than these ones. So each time they give you a resultant which is smaller than the individual forces, it means that the parallelogram was supposed to be drawn in this direction, that the angle between the two individual forces is an obtuse. But now in this case, the resultant was bigger. So the parallelogram should be in this form so that the angle between the two individual forces is acute. So in short, they wanted an acute angle at the end. And basically that's what they wanted. So force diagram should be drawn with a ruler. So required candidates to draw a correct force diagram. And like I've told you, force diagram should be drawn with a ruler. And find unknown force given a resultant and of two forces. It was a popular question, meaning it was attempted by many students. However, some failed to draw a correct force diagram. So if you draw using freehand, it is not okay. 2, some failed to determine the magnitude of the force and its direction. So using cosine and sine rule was a challenge. Advice to teachers: emphasize the use of straight edge. Straight means drawn with a ruler when drawing a force diagram. So force diagrams must always be drawn with a ruler, and the ruler should be reasonably new. Then another advice that guides the students on the proper use of cosine and sine rules. So sine rule and cosine rule, you cannot run away from them as long as you enforce resultant of forces. So this topic was under composition and resolution of forces. It's under the section of statics, because statics means there are forces but there's no motion. Then question 3 is from the section part of numerical methods, and in particular linear interpolation and extrapolation. So it says the table below shows the velocity v at an instant t seconds of the particle moving in a straight line. Calculate part A, the velocity of the particle after 1.5 seconds. Part B, the time when the velocity is 13 meters per second. So yeah, the first thing to do is to extract out the necessary values. You realize that 1.5 is between time is between 1 and 2. So we need to extract out these values. So that 1 is here, 2 is here, and 1.5 is in between. And this value is the unknown. Then we can now equate the quotients. So V1 minus 2 divided by 7 minus 2 will be equal to 1.5 minus 1 divided by 2 minus 1. Then you can simplify and make V1 the subject, and that's what they want. Then part B, the time when the velocity is 13 meters per second. 13 is beyond this, so that becomes extrapolation. When it is extrapolation, you use the two immediate values. So I want to use 8 and 10. If you use any other pair, it will not be okay. Then you still equate the quotients. You are going to say T2 minus 3 divided by 4 minus 3 is equal to 13 minus 8 divided by 10 minus 8. Then you make T2 the subject, and that's what they wanted. So the question required candidates to locate values and use the gradient to find values, gradient or equating quotients correctly. It was a very popular question, however, some candidates failed to locate the values. Others failed to have the necessary specified way of answering. So one, choosing the correct values, whether it's interpolation or extrapolation, is very vital. And 2, you don't overround off. So others rounded off to a whole number, and it was a challenge to candidates. Actually, let me first go back to the table. Some students are funny. Do you know how funny they are? Do you see these values? When they see that the values are rounded whole numbers, they also think they must give their answers to a whole number. But that is not the case. That is called premature approximation. So even if the values are to whole numbers or to 1 decimal place or to 2 decimal places, the value of the answer should be 4 decimal places, unless they specify here that give your answer to this number of decimal places. But each time they do not, get used to writing your answers to 4 decimal places. It will save you a lot. So advice to teachers: emphasize location of values in the given ranges. Location, whether it's interpolation or extrapolation. Emphasize use of gradients, equating correctly. For me, realize that I didn't use gradient. I just put x values on one side, y values on the other side. It is also okay. It is also okay, provided you are consistent. Another one can choose to say, let me use ratio gradient, whereby you put y values up, x values down, y values up, x values down, and you equate. It is still okay. Then emphasize high level of accuracy. High level means you don't over round off. Don't over round off. Use for decimal places. It is recommended. So now we shall go to question 4. Question 4, it says the table below shows the unit prices and quantities of food items in the year 2005 and 2010. Calculate the weighted price index of 2010 using 2005 as the base year, and then comment on your result. So do you see here, because weighted price index is either aggregate or average, but what should be in your mind is that each time they don't specify, then it must be average. Each time they don't specify, it must be average. So we are going to use the formula for weighted average price index, and the quantities will now act as the weights. So first, let's get this numerator, which is summation of price in the current year divided by price in the base year, everything multiplied by the weight of that commodity. So that becomes that, and when you use the calculator, I'll come up with this as the answer. Denominator, we shall need the summation of all the weights, which is 140. Then we can now quote the formula, substitute, and get the answer. This should not have a percentage sign. Some students are funny. When you put a percentage sign, it is now no longer a price index. So percentage is put on a comment. Percentage is put on a comment. And that's what they wanted. So required candidates to determine weighted price index and give a comment. However, some failed to use a correct formula for weighted price index. So when you use weighted aggregate price index, it is no longer okay. Others failed to give a comment on the values obtained. So the value obtained, you must give a comment in percentage form. So advise that they should teach the different forms of weighted price index. So that question was from the section of part of statistics and probability, and in particular it is price indices. Then question 5, it says a force of F newtons acting on a particle of mass 4 kilograms is acting on a particle of mass 4 kilograms whose position vector at any time t is given by this. Find F in vector form when t is pi over 3. So here we know this position vector at any time t, it means that I will use calculus. So if you see t, if this is variable, it means you have to use calculus. And because you know the position vector, you can get velocity by differentiating with respect to t. Then also get acceleration by differentiating velocity with respect to t. And when I get acceleration and mass, I can get the force. So force will be ma, which is this, but I know the value of t, so substitute where there is t. Then remember to set your calculator to radians, and you'll be able to get those values. Because this is in this, there's a tilde here, it means that they want the answer in vector form, so you have to stop there. And that's what they wanted. So the question required the candidates to differentiate displacement, velocity, and acceleration and apply Newton's second law, that is F equal to ma. Weakness was failure to differentiate the expression, and 2, failure to convert to radians, and omission of a vector symbol. Actually, most students know what to do, but this last step puts them off. Did you see this symbol I put, the tilde? Let's first go back and you see. Did you see this symbol? It is a must. Actually, that is one of the reasons why, you see here, they gave me in form of ij, but I converted it to a column vector, because if you don't convert to a column vector, I must see I tilde j tilde throughout, I tilde j tilde throughout. But when you put in column vector, it saves you a lot. So you bypass the tildes, but this one still needs a column symbol, vector symbol. So these vector symbols are needed. All these ones, they are needed. And don't again put it on mass, because mass is never vector. Mass is scalar. Mass is scalar. So make sure you don't bypass those vector symbols. And 2, differentiate. Each time you see t in the expression of position vector, it means it is variable. Or in the expression of velocity, it means it is variable. So there you have to use calculus. If there is nothing like t, if it is constant expression or vector, then you have to use the equations of motion. And remember, each time you see trigonometry, the calculator should be set in radian mode. So that question was under vector mechanics and in the part of dynamics, because there was motion. Then question 6 says a metallic can is in form of a cuboid. Its dimensions are 2.7, 4.80, and 3.281, correct to the given number of decimal places. Determine the possible minimum and maximum values of the container correct to 3 decimal places. So cuboid volume over cuboid is length times width times height. So you have to multiply all the 3. But when they say minimum, you have to minimize. So these are the error in the length, error in this. So you should be keen. Some students remove this 0, then it is no longer okay. There's a reason why it was put. So these are 2 decimal places, so the error should be 0.005. 3 decimal places, error should be 0.0005, like that. Minimizing product means you subtract. Then use a calculator to come up with that value. So you first write when there are many decimal places, then you show us how you round it off. Then minimizing, you add. There should be plus here, maximum, maximum, maximum. Then you can use a calculator. And remember to round off to the required accuracy. So all the individual errors correct, that is 1 mark. Then maximizing, output to required accuracy. Sorry, this is minimizing, this is maximizing, required accuracy. So the question required candidates to identify errors and find the maximum and minimum values of the volume of a cuboid. The weakness was failure to find the errors and volume of the cuboid. Volume, we are supposed to remember that volume is LWH, length times width times height. That was a challenge to many. Then failure to round off to the correct accuracy, to the given accuracy. Even if I've told you that it is advisable to use 4 decimal places, that only works when they don't specify the accuracy. In this case, they have specified 3 decimal places. So if you use anything beyond that or anything below that, it is no longer okay. So follow instructions. They only wanted you to get maximum and minimum. Don't proceed. Some students were proving that they know more. They even got the percentage error. That is not allowed. Only write what they want and stop. Advice to teachers: guide students to find errors of numbers in relation to the given number of decimal places, and emphasize following instructions. Only answer what is needed, and what they have not asked, don't tamper. So that question was under numerical methods in the topic called errors. Now this one will be under statistics and probability, and the topic is discrete random variables. Each time you see commas, it is now a discrete random variable. So it says a discrete random variable x has a probability function given by this. Given that ex is 3, ex means expected value. Find the value of n. So here, total probability is always equal to 1, so sum up all the values. Do you see these dots? They are needed. Because they are here, means that there are some values here up to n, which you don't know yet, but you will know with time. So this is a standard series, and it is there. The formula is there in the logbook. Adding all the counting numbers, the first n counting numbers, the formula will be given by this. It is there in the logbook. Then you simplify to get equation 1. Then the second equation will be got from the expression for expected value. X probability of x equal to 3. So multiply. So when I multiply, I come up with this. This will be 1 squared, 2 squared, up to n squared will be equal to 3. Also, this is a standard series, so it is there in the logbook. It will be given by this. Then you can now get equation 2. Now I need to solve these two equations simultaneously. Since they are connected by product, it is better to divide, because when I divide, this will go and this will go. So let's see that in the next slide. So this will go to come up with this as this. So I remain with this. Divide throughout by 20 and take this on this side, then make n the subject, and that's what they wanted. So the question required candidates to use probability sums and expectation expression to find the value of n. Failure to state and equate correctly the probability and expectation expressions. So those dots, students thought they are not there, but they were there. Why did you remove them? So when you remove them, there's nothing to do. Correct substitute correct induction formulas from the logbooks. So these logbooks have formulas, and if you don't use those formulas, then marks will be going away. So advise that emphasize use of logbooks. I think you have seen this word has come up most times. Use logbooks, because they are given to you. So if you don't use them, then there's no mercy. We can't tolerate that. Question 8, it says a boy can swim in still water at a speed of 2.5 meters per second. The boy wishes, this word wish is vital, wishes to cross a straight river which is 50 meters wide and flowing at a speed of 3 meters per second. He sets off at an angle of 60 degrees to the bank of the river. Find the time it takes him to cross the river. To determine the boy's resultant velocity. So one, we have two banks. The river is 50 meters wide. Then the boy moves at an angle of 60 degrees to the bank with a speed of this. But the river is also flowing at a speed of 3 meters per second. So he will reach somewhere. This is where he will reach. So he sets off in this direction, but reaches this side on the other side of the bank. This is now the resultant. And this is what they want here. And the time it takes, it means, remember, time is distance over speed. Now that speed we use is called resultant speed or resultant velocity. So by cosine rule, we can have that. Cosine rule means I have this angle, I have this, I can use it to get this. So that gives you the value of V as that. That's the resultant velocity. Then time taken, I'll need to get this distance, because the time we use the formula that distance along the resultant divide by the resultant force. Distance along the resultant divide by the resultant force. So I'll need to get this distance, AB. I need to get the distance AB. So by sine rule, theta is equal to theta, sine theta over 3 is equal to sine 6 over this, to give you the value of theta as that. That means that alpha will be equal to that. Therefore, if I use sine alpha, it will be equal to 50 over AB. Therefore, AB will be equal to this. Now that I've got AB, I can get the time taken. Distance along the resultant over the resultant's velocity, to give you this as the time taken. And that's what they wanted. So analysis, the question required candidates to draw a correct vector diagram with a ruler and find the time for crossing at a specified angle and resultant velocity. Weakness was failure to draw a correct vector diagram and failure to explain the resultant velocity. So still is this side, then resultant is where the person wishes to go. Advice to teachers: emphasize the use of straight edges. Do you see this word straight edges? It is coming up each time in mechanics. So questions of forces, remember to use a ruler. Remember to use a ruler. Here they are not using the word ruler in particular because some can use a pen as a straight edge, isn't it? You can have your pen, second pen, then you use it to draw a straight line. It is okay. That's why they're generalizing it to word straight edge. Whatever you use, what we want is a straight edge. Then emphasize magnitude and direction in explaining resultant. Remember, resultant is velocity is a vector quantity, so we need magnitude and direction. So in this case, the resultant, the direction was this one we got. Do you see this alpha here? Is the direction we got here. This alpha. So direction of the resultant was also needed. So that was section A. Now we are good to start on section B. Section B also has 8 questions and you answer any 5. But for the sake of revision, we shall answer all. So question 9 says, the table below, which is this now, shows the distribution of time in minutes spent by students revising for a test. Part A, calculate the mean revision time. And part B, Roman 1, draw a histogram for the data. And Roman 2, use your histogram to estimate the model revision time. So these are inequalities. Each time you see inequalities, it means the class is the same as class boundary. Some students are funny. When they see this less than, they think it is maybe 9.9. No. No, no, no. So here I can put any inequality of my choice. I can put less or equal to, or I can put just less than. Same applies to this. I can put just greater than, or I can put greater than or equal to. Any inequality of my choice, but your work is to remember that each time you see an inequality, it means the class is the same as class boundary. Then 2, the letter they use here is what you should use in place of midpoint, in place of mid mark. So time, I think you see I've just removed the inequality. What I get is what I write. Then frequency, it was given the question. Then I have to add up all this to get the total frequency and write it here. Then the class width, remember these widths are not the same. So this minus this is 10, this minus this is 5, this minus this is 15, this minus this 15, this minus this 10, this minus this 5, this minus this 10, this minus this 10. From the class width, I can now get frequency density because they told us to draw histogram. Histogram for unequal class width, we use frequency density. So this divided by this is 2, this divided by this is 3.6, this divided by this is 4, this divided by this 3, this divided by this 5, this divided by this 6, this divided by this 3, this divided by this 1. So next will be the mid-mark because they will ask for the mean. So mid-mark means this plus this over 2, 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 and this plus this over 2. Then I can multiply now frequency times the mid-mark to give me ft. So this times this, 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 and this times this. Then I need to get the total of all this, which will give me that. So now that I've tabulated, I can now go and get the mean. So mean will be summation of ft over summation of f. Substitute, get the answer for decimal places. Then part B, they wanted a histogram. Histogram, you'll need a graph paper, draw your scales, horizontal and vertical axis. Get a suitable scale for the horizontal axis using intervals of 2 centimeters, and label the axis. Do the same for the vertical, use intervals of 2 centimeters and get a suitable scale, and also label the vertical axis. Then next is to plot. So histogram, we use bars. So from 0 to 10, the bar will have a height of 2, which is here. From 10 to 15, the bar will have a height of 3.6, which is here. From 15 to 30, the bar will have a height of 4, sorry. From 30 to 45, the bar will have a height of 3. From 45 to 55, the bar will have a height of 5. From 55 to 60, the bar will have a height of 6. From 60 to 80, the bar will have a height of 3. And lastly, from 80 to 90, the bar will have a height of 1. So that is our histogram. But they also told us to use it to estimate the mode. So the highest is this. Highest is this, meaning we shall join a line from here to here. And also join a line from here to here. And drop a perpendicular from the intersection to meet the horizontal axis. Then we can read off that value, and that will be the model revision time they wanted. So analysis, the question required candidates to calculate the mean and estimate the mode using a histogram. Weakness was failure to identify the correct class widths and values of x. So when you add and subtract 0.5, then it is no longer okay. Then failure to determine the frequency density. Frequency density, remember, it is frequency over class width. So when the class width is not okay, even the frequency density will not be okay. Scale and label. So scale should be uniform and the axis should be labeled. Failure to draw a histogram and locate the mode. Failure to draw because you are supposed to get the frequency density. So I think you can see the answer is a chain. When the class width is not correct, however much whatever you do after that, the answer will never be okay. So before you go to other things, first double check the class width because it controls a lot of things. It controls a lot of things. Advise that emphasize the class width, scaling, labeling, and drawing a histogram, and locating the mode because it was a challenge to many. Then question 10, it says part A, a ball is thrown with a velocity of this, vertically upwards from the ground. A girl on a balcony of a building 10 meters high leaned and caught the ball on its way down. Part A, or Roman 1, calculate the time taken before the ball is caught by the girl. And Roman 2, the speed with which the ball was traveling when it was caught. So there's part B, but let's begin with part A first. So part A, using the second equation of motion, I'll substitute displacement, initial velocity, and g is a constant. So I have t as the only unknown, meaning I can solve the quadratic to get the two values of t. But t cannot be this because therefore t is equal to this. Now, why isn't it equal to that? Let's go back to the question and we see. Remember, both are positive, but why did we ignore that? A ball was thrown with a velocity of this, vertically upwards. A girl on the balcony of a building 9 meters high leaned and caught the ball on its way. Calculate the time taken before the ball is caught by the girl. So this means that if it was moving like this, vertically upwards, here at this height of 9 meters, the first time is when it was moving up. That was the time of 0 point something. Then the second time is when it is now moving down. Now the girl caught the ball on its way down. Not this one, it is moving up. He caught it when it was coming down. So we can't take the first time. We shall take the second time when it is at that height. So that's the reason why we ignore the smallest time and take the bigger time, because that time is when the ball is at this height above the ground. But the smallest time is when it is moving up. Bigger time is when it is moving down. Then they also said, find the speed with which the ball was traveling when it was caught. So V is equal to U minus GT. Substitute for V, for G, and for T. You'll come up with this. So negative, why is it negative? Because upward is positive, meaning downward will be negative. So it was moving downwards, that's why you're seeing this negative sign. Therefore, you can conclude that the speed will be, because speed is magnitude, so speed will be this. Then now we can go to part B. Part B says, a particle travels with an initial velocity of this. From a point with a position vector this, the particle moves with an acceleration of this. Determine, Roman 1, the position vector of the particle after 5 seconds. And Roman 2, the distance covered in the 5 seconds. So we know the initial velocity vector, we know the position vector, and we know the acceleration. Do you realize something here? Now here, we are not going to use calculus. Do you know why? All these ones are constant. If you look at these values, there's nothing like t. So using calculus is not okay. So when there is nothing like t, it means they are not varying. They are constant values, and therefore we have to just use the equations of motion. So I'll come here and say that U is that, OP is that, and A is that. So these are the ones I'm going to use. So I'll come and say that in the second equation of motion, S is equal to UT plus a half AT. So U is that, T is that, A is that, A is here, and T squared is there. Then I can use the calculator to come up with this. So this one gives me this, the whole of this gives me this. In the end, I'll come up with this as the displacement. So if the particle moves from P to Q, then S is equal to PQ. That means that S will be equal to OQ minus OP. So that means that OQ, which is the position vector, will be equal to OP, which is the initial position vector, plus the displacement, initial position vector plus the displacement. You'll come up with the new position vector. And vector form, I can write it in that form. The tildes, don't forget them. Then Roman 2, they said distance covered. Now here, this is where the trick comes in. There are two words they usually use. One, distance covered, another one, in the given time, or distance from the origin. Those two words are different. When they say distance from the origin, it means magnitude of the position vector. When they say distance covered, it means magnitude of the displacement. Magnitude of the displacement. So in this case, they want magnitude of the displacement. Meaning that I have to go back to this displacement, this one, and I get its magnitude. And that will be the answer. So question required students to find time and velocity at a specified height on a vertical projection. And part B, determine the position vector after 5 seconds and the distance traveled in 5 seconds. Weakness was failure to identify the correct height and acceleration due to gravity value to use. So if you use 9.81, for those who do physics, not okay. If you use 10, it is not okay. Then distinguish between position and distance for. Do you see that word? Position and distance for 5 seconds. Here, distance of 5 seconds, it is magnitude of displacement. If they said distance from the origin, then you would say magnitude of position vector. Identifying that it was a uniform motion. So some students still wanted to use calculus. Calculus is for non-uniform. Where there is a t in S, maybe that means it is changing with time. That is variable and non-uniform. But here, when it is constant or uniform motion, we use equations of motion. So advice teachers emphasize height and acceleration due to gravity, and to distinguish between uniform and varying acceleration. So now shall go to question 11. Part A says, using trapezium rule with 6 ordinates, estimate this integral, giving your answer correct to 3 decimal places. So let's begin with that trapezium rule. So we begin with the strip width with that. Then we can now tabulate values of n, which are the ordinates. They should be 6. Then the values of x, starting from the lower limit and keep on adding this, plus 0.2, it gives this, plus 0.2, plus 0.2, plus 0.2, plus 0.2. Then you can now go to the values of y, extreme values. So now we need to use this formula. This one. So when x is 0, what is this whole value? That's what we call the value of y. So when x is 0, we shall get this. And when x is 1, we shall get this. Then get the total, which is that. Then now the intermediate values. When x is 0.2, we get that. When x is 0.4, we get that. When x is 0.6, we get that. When x is 0.8, we get that. I think you are seeing, let me first see the accuracy. They want the value answer to 3 decimal places, but the table is to more than 3. It is advisable to add 2 more. That's why you're seeing here 5 decimal places. That is called boosting accuracy. If by mistake the table, the values are to 3 decimal places, then it is no longer okay. So I'll now code the formula for trapezium rule. A half times the h, in brackets we put summation of the extreme values plus 2 times summation of the intermediate values. Then you can get the answer to 3 decimal places. That was Roman 1. Then Roman 2. Given that this is equal to this, find the percentage error for the estimate in part A. So this is the exact value, and remember percentage error will be exact of minus approximate, everything divided by the exact, times 100. Then you get the output. Then Roman 3, or part C, suggests how the accuracy can be improved. Accuracy can be improved by increasing the number of ordinates within the same limit. And that's what they wanted. So analysis, the question required candidates to estimate the approximate value and find the percentage error, hence giving a comment. Weakness was failure to distinguish between ordinates and sub-intervals in order to find h. And remember, h is where everything begins from. So if h is not okay, the entire question will now no longer be okay. So in such a question, you should be wise. A question which is a chain, whereby one part controls the other part, you should be keen every step you do. So here, not getting the correct value of h, however good your approach will be, there will be 0 mark. There will be 0 mark. Then 2, use of few decimal places than the expected number of accuracy. Using 3 and below in the table is not accepted. Then advice to teachers, emphasize the difference between ordinates and sub-intervals. And 2, emphasize high level of accuracy and correct definition. Correct definition means exact minus approximate. That's the correct definition of an error. Question 12. The cumulative distribution function, capital Fx, of a continuous random variable x is represented graphically as shown below. Part A, find capital Fx, then the probability of x greater than 1 but less than 2.5. So let's first find, I think first thing to realize that these are all straight lines. These are all straight lines, meaning we shall need the equation of a straight line using the coordinates. So this coordinate is -1, 0, and this is 0, 1/8. So you can get the equation of that straight line like that. So using this and this for this range or for that interval, we can get the equation by equating gradients and making y the subject. Then using these two coordinates for this interval, we shall still equate gradients and make y the subject. Then using these coordinates for this interval, we shall equate gradients and make y the subject. Therefore, capital Fx will be given by that, and that's what they wanted. Then Roman 2, they wanted the probability of x greater than 1 but less than 2.5. It's the same as f of 2.5 minus f of 1. So substitute f2.5, 2.5 lies here. So we shall use this function to get f2.5. Then f1, 1 lies here. So we shall use this function to get f1. Then that should be the answer. Then part B, Part B, they said find Roman 1, the probability density function, that is PDF or small f of x, and also the expected value of x. So from capital F to small f, we have to differentiate. So I'll differentiate each function. For that is that one is that. Differentiate all functions. This one gives that, this one gives that. Then I can quote small f of x. Then the ex is integral of x fx. So integrate. So this times x, it gives this times x gives that, this times x gives that. Then I can integrate, substitute, limits, and get the answer. And that's what they wanted. So question analysis, the question required candidates to estimate the cumulative distribution function using gradients of lines, and hence find the probability density function and the mean. Weakness of candidates was failure to use the concept of gradient to find the equation of capital Fx and writing the expression of capital Fx after everything. Then also failure to integrate when determining the mean. So mean, you have to integrate. Then advice to teachers, emphasize graphical approach in teaching cumulative distribution function and use of the concept of gradient. Question 13 says, a light inelastic string of length 80 centimeters is fixed at one end R and carries a particle of mass 0.1 kilograms at the other end S. The particle moves in a horizontal circle with angular speed of 5 rads per second. Determine part A, the tension in the string, and part B, the radius of the horizontal circle. So you need to first make a sketch of the conical pendulum. Particles there. It moves in a horizontal circle in that path. So length, this RS is 0.8. And the weight of the particle is 0.1 grams. Tension, arrows should point towards each other. So cos theta, if I use this triangle, cos will be equal to adjacent over hypotenuse, which will be r over 0.8, implying that r is 0.8 cos theta. So applying Newton's law, second law of motion horizontally, it gives you, resolve this tension this side, it becomes t cos theta. Then this will be ma. Remember, a is r omega squared. So substitute for r, and you realize that this cos can cancel. You remain with the value of t as 2 newtons. Then for Roman 2, they wanted the radius of the circle. So resolving vertically, you'll come up with t sine theta is equal to 0.1 g, meaning I can substitute for t and get the value of theta as 29.34. After getting the value of theta, I can remember the expression for r in terms of theta, substitute for theta, and get the value of r. And that's what they wanted. So analysis question required Candace to find tension and the radius of the horizontal circle. Weakness was failure to draw a correct force diagram. It must be drawn with a ruler. Failure to convert the units. And also failure to resolve and relate radius and length of the string. Then advice to teachers: teach circular motion effectively and emphasize resolving and conversion of units. So you have to use SI units. Question 14, part A says, use the graphical method to estimate the root of the equation this in the interval this. So here we shall need to tabulate. Shall get values of x and y. So in this interval shall get at least 5 values. If x is -2, y is that. When x is -1.8, y is that. When x is -1.6, y is that. When x is -1.4, y is that. When x is -1.2, y is that. And last, when x is -1, y is that. So 1, 2, 3, 4, 5, 6. So that is good to go. We need at least 5 plottable values. And I think you realize that here I've used 2 decimal places because they are the ones which are plottable. Then we shall come and get our graph paper and draw the axes. We have more negative, everything is negative, so we have to put it there. Then also vertical scale. Then now we can plot using those values. So plotting, -2 goes with -5, which is here. -1.8 goes with -1.46, which is here. -1.6 goes with 1.21, which is here. -1.4 goes with 3.11, which is here. -1.2 goes with 4.34, which is here. And -1 goes with +5, which is here. After that, we can now join using a reasonably smooth curve. Okay, then you can show where the root is, and it is -1.7. So that was part A. Now we shall go to part B. Part B says, using Newton-Raphson method, find the root of the equation this, taking the approximate root obtained in A as the initial value of x naught. Give your answer correct to 3 decimal places. So fx will be that, differentiate it to get f prime x, then quote the formula for NRM and substitute for fx and f prime x. So x naught is -1.7, then substitute for xn to get the new x1, which is that, then substitute again to get x2, which is that. So there you stop, because these are, when you round off 3 decimal places, they are the same, exactly the same values. Therefore, you can come and state the required root. And that's what they wanted. So the question required candidates to estimate the root in a specified interval. Then to use NRM to obtain the root correct to 3 decimal places. Weakness was failure to get the correct table values within the range. It must be between from -2 up to -1. Some students were writing -2, -1, 0, 1, 2. No, that is not what they want. All the values must be in the given range from -2 to -1. And 2, failure to draw a graph with a uniform scale and axes labeled. Axes must be labeled and the scale has to be uniform. Then 2, failure to distinguish between performing a dry run and performing iteration. So some were tabulating. That is not okay. That is called dry run. Here we want to see physical substitution. Physical substitution is needed. So question 15 says an examination consists of 120 multiple choice questions. Each question has 4 options for which there is only one correct option. Part A, if a candidate who sat for the examination is chosen at random, find the probability that a candidate obtained between 20 and 40 inclusive correct options. Then Roman 2, exactly 41 correct options. And part B, determine the pass mark for 80% of the candidates to pass the examination. So let's begin with part A. One should realize that this is a binomial, but n is greater than 30, so you have to approximate by carrying out continuity correction. So you'll come and say that what we are given is n, p, and q. From there I can get mean, which is np, to give you 30. Then also standard deviation, square root of np q, which is that. You can either leave it like this or you round off to 4 decimal places. It is still okay. So now I can carry out continuity correction. This one is written by this because they said inclusive. That's why you see O equal to. Then continuity correction, this becomes this. So after continuity correction, it is you to choose because for discrete, these two inequalities mean different things, but for continuous, they mean the same. So that's why here I chose to use greater than. But even if you maintain O equal to, it is still okay. Then you standardize because I know the mean and I know the standard deviation to get the Z values to 3 decimal places. Then I can get the corresponding probability of that Z value. So phi of 2.214, you'll come here, 2.214. So 2.21 is this, which is this probability. Then 4 is 1, but it has to be 4 decimal places, so write like this. When you add the 2, you'll come up with 0.4865, which is here. Multiply by 2 to get the answer, which is 0.9730. And that's what they wanted. Then probability of exactly 41, that is x equal to 41, by continuity correction becomes x, so you just say plus or minus 0.5 to give you x is greater than 40.5 but less than 41.5. So standardize to get the Z values and then get the corresponding probabilities. Phi of 2.424 minus phi of 2.214. The one of 2.214 is set in part Roman 1. Then the one of 2.424, you'll come here still. So 2.424 4. So 0.4922 plus 0.0001 to give you 0.4923. So that's why that came about, and again you get the answer. Then in part B, we shall go back and say, part B, they say determine the pass mark for 80% of the candidates to pass the examination. 80%. So probability should be 80%. So 1, we know that let x1 be the pass mark. So probability of x greater than or equal to x1 will change by continuous correction to become this. Then you standardize to give you that. So let z1 be equal to this. It implies that probability of z greater than z1 is equal to that. Therefore, 5 negative z1 will be equal to that. Therefore, 5 negative z1 is 0.3. Then you got the tables. 0.3 corresponds to 0.4842. So 0.842 is that. Now that I've got the z value, substitute it back here and make x the subject. And that's what they wanted. So question required candidates to find probabilities using normal approximation to binomial and also determine a pass mark above 80%. Weakness was failure to identify the probability of success and failure, mean and standard deviation. Add and subtract the continuous correction was a challenge. Then also reading the z value and subtracting the continuous correction was a challenge. So advice to teachers: emphasize normal approximation. Normal approximation, you must be careful with it to binomial and when to add and subtract in the continuity correction. So you know when do I subtract and when do I add. Emphasize reading z values. So question 16 says the diagram below shows a uniform lamina, which is this. Determine part A the distances of the center of gravity of the lamina from the sides AB and AH. One thing we realize is that this lamina is symmetrical. And we all know the center of gravity always lies along the line of symmetry. So the distance from AH is already known, it is this over 2. But the one from AB, it is not known. Then you also realize that AB is the distance that go downwards, so there should be some negatives somewhere. So shall come and say, let rho be the weight per unit area because it's a lamina. Then you can tabulate. So you have the figure B, ABCH. Let's see ABCH. ABCH is this one. It's a rectangle, so area will be length times width. And because they want weight, you multiply by rho. And the center of gravity will be the lines of symmetry, along the lines of symmetry, which will be this. So it will be half of this and half of this. So weight will be area times rho to give you 6 rho. Then distance will be negative because we are now moving downwards. Then another one is figure DEFG. Let's see that. DEFG is this. It is also a rectangle. Area will be length times width. then weight will be times rho. Then the length distance from AB will be first this 1.2, then plus half of this. So we shall come and say weight is that, then negative of this. Then next will be the whole lamina. We add the total area, which is this plus this, to give you 9 rho as the weight. Then the distance, we don't know it, so just call it y bar. Then taking moments is first weight and distance. So this times this gives you this. Then this times this gives you this, will be equal to the total, which is this times this. Simplifying gives that, therefore y bar is that. So the required distance from AB is 1.3 and the required distance from AH is 2.5. Then part B, they said, part B, if the lamina is suspended from the vertex A and rests in equilibrium, calculate the angle which the side AB makes with the vertical. So if it is suspended from vertex A, then the line of action of the weight must pass through point A and also the center of gravity. So we shall come and draw that. Let theta be the angle which side AB makes with the vertical. So the weight should pass through the vertex A and the center of gravity. So is the x coordinate, y coordinate, then the line of action of the weight is that. So the angle side AB makes with the vertical, this is now the vertical, it is this theta. So we have already got a right angle triangle, so we can get the value of theta. And that's what they wanted. So the question required candidates to find the center of gravity of the lamina from sides AB and AH, and also determine the angle AB makes with the vertical. Weakness was failure to find the weights and the distances from sides AB and AH. Then also failure to take and equate moments, and failure to locate the angle. In short, it was a problem to many. So advice is to emphasize weights and location of center of gravity. Then 2, emphasize taking moments and emphasize the length of the sides to determine the angle.